Hello everyone, this is the video explanation on the chemical reactions of amines and the continuation of the previous video of the chemical reaction of amines. Now in this video I'll be discussing the chemical reactions, two chemical reactions, that is reaction of amines with nitrous acid and reaction of amines with Arylsulphonyl chloride. Now the first one, the reaction with nitrous acid. Now some important points before going into the reaction. Now the first point is, now nitrous acid is prepared as sodium nitrite plus HCl. Sodium nitrite plus HCl will be getting HNO2 plus NaCl. Now in this reaction, the nitrous acid used is freshly prepared. Only freshly prepared nitrous acid is used in this reaction. Therefore, as the chemical reaction takes place, that is RNH2, amines reaction with nitrous acid, Na, sodium nitrite and HCl should also be present in the solution to continue preparing freshly prepared nitrous acid. Therefore, our product here will be N2Cl minus and plus. Now this is an diazonium salt. Therefore this will be alkyl diazonium chloride. This a diazonium salt is from, and these diazonium salts will be discussing in the coming videos. Now when this diazonium salt on hydrolysis, when it is on hydrolysis, the OH minus comes and bonds with the alkyl groups, and then this leaves along with the bonding electron, it goes and then leaves. Therefore, nitrogen gas is removed, and HCl is the H plus takes this HCl, and nitrogen gas is released. Therefore, we will be getting alcohol here. Therefore, the removal of nitrogen is supported by entropy. Therefore, our resulting product here is an alcohol. Now, all the three classes of amines, that is our primary, secondary, and tertiary amines, react differently with nitrous acid. In this, the nitrous acid reaction is very common for only primary, alkyl, and aryl amines. Now, let's check for aryl amines. C6H5, that is our benzene ring, reacts with nitrous NaNO2 plus HCl. Since it has to be freshly prepared, it is present in the solution. From here we'll be getting our HNO2. Now we'll be getting C6H5 N2 plus and then our Cl minus. This is benzene diazonium salt or benzene diazonium chloride. Now benzene is the benzene ring, diazome is two nitrogen atom, diazonium is because of the positive charge, and then our chloride is, therefore this is known as benzene diazonium chloride. The reaction of nitrous amines with nitrous acid gives diazonium salts, and these diazonium salts on hydrolysis we will be getting the corresponding alcohols. Now let's check the mechanism. The mechanism this is our this is our nitrous acid. Now when nitrous acid our HCl supplies this. Now the nitrous acid here, our nitrous acid is here. Now H plus, there is the donation, and then double bond O N O, and then H, one more H has been and bonded, therefore we'll be getting here bond. Will be a positive charge here. Now water is also, we know that water is also good leaving group. Therefore, along with the two bonding electrons, this goes, the water molecule leaves this group. Therefore, there's removal of water, and we will be getting N plus, because the two bonding electrons, the nitrogen, will be positively charged. This is known as nitrosonium. This is known as a nitrosonium ion. Now the nitrosonium ion is an electrophile, and this structure is already resonance stabilized and acts as an electrophile. Now this is also the main ingredient in the reaction of nitrous acid with amines. Now primary amines comes into play here, R and H2, the base. So this will be our nucleophile, and then our electrophile here is. Now the lone pairs are donated here, and then we'll be getting here R and the two hydrogen. Nitrogen would become positive charge, and then since the N and N, nitrogen has bonded with nitrogen of the nitrosonium ion, the N would be here and this would be here. Now from here we will be getting R and now allow the two bonding electron pairs along the two bonding, and this bond breaks and the two bonding electron fills the deficiency of nitrogen atom. Therefore we'll be getting here R and H and double bond O. Now this also is also nitrogen atom. These two bonding electron pairs. Now in nitrogen atom, when this bond in this ion, when there is this bond goes here, breaks up and then adds up here, and then at this time when this bond breaks up, the bonding electron, the two bonding electron pair comes and adds up to this bond, and then the hydrogen atom, this hydrogen atom comes and adds up to the oxygen atom. Now when this bond breaks and adds up to oxygen atom, as soon as this bond breaks up, the hydrogen atom, this bonding electron pair comes and makes a new bond. The oxygen atom, the hydrogen, this bond breaks and then goes to oxygen atom, and then the hydrogen at the proton comes and adds up to the oxygen atom. Therefore we will be getting here, there is proton transfer takes place. There is a transfer of proton here. Therefore we will be getting here R N double bond and OH. Now there is proton transfer as well as tautomerism takes place. Tautomerization takes place because the tautomerization is when an atom having an oxygen atom has an acidic hydrogen nearby. Therefore we know that this oxygen atom has an acidic hydrogen nearby. Therefore this tautomerism takes place, and then we will be getting here R and double bond would be formed from here, and then the H, there was proton transfer, the OH will be formed here. Now this OH will be positively charged. Now sorry, I have written this here from here. Now this is the product here. Now this product, we have one, the hydrogen plus here, there is a proton remaining here in the solution. This proton comes and adds up to this OH, the OH group, and then the product here, this the H plus the proton that was present in the solution comes and adds up to this OH group, and then our product here would be, there would be already one hydrogen is already here. Since another hydrogen comes and adds up here, there would OH2, and our hydrogen oxygen atom would have a positive charge with it. Now there would be removal of water, H2O minus of H2, removal of water, H2O along with the two bonding electron pairs, it goes away. Therefore there would be removal of water, and then we R and double bond, and since water was already along with the two bonding electron, it left. Therefore nitrogen would become positively charged. Now to complete its octet, since nitrogen atom should have nitrogen is here is 3 bond, but here only is only 2 bond. To complete its octet, there is resonance takes place here. Resonance takes place here. Therefore, we know that nitrogen has a lone pair. Now, this lone pair in nitrogen atom comes and adds up to this bond. Therefore, we'd be getting N plus triple bond, and then this is a triple bond, and then we know that our chlorine here, the chloride ion here is present in the solution. Therefore, the Cl minus here would be present in the solution here. Now, therefore, this is our alkyl diazonium salt. Therefore, since this is more stable, nitrogen here is, since this is more stable than this compound, therefore, to complete this octet, resonance takes place, and then we get our resulting product as the diazonium salt. Therefore, this reaction is also one of the chemical reactions of amines, which is an important chemical reaction. In this reaction, also only the primary amines are the reaction of primary amines with nitrous acid is very common, and secondary and tertiary amines, they react with nitrous acid in a very different manner. Therefore, we will be discussing that in this chapter. Therefore, to conclude here, let's check that the nitrous acid, the reaction of amines with nitrous acid. The nitrous acid should always be freshly prepared so that our resulting product is obtained in good yield. Now, our fifth chemical reaction, that is reaction of amines with arylsulphonyl chloride. Now, this arylsulphonyl chloride is also known as Hinsberg's reagent. Arylsulphonyl chloride is also known as Hinsberg reagent. Hinsberg reaction, and this Hinsberg reaction is also used to differentiate between primary, secondary, and tertiary amines. Why is it that so? We'll be discussing that in the mechanism. Now, what is the Hinsberg reagent? Hinsberg reagent is aryl, means only aryl, means there is no alkyl here. Aryl, keep that in mind. Aryl means C6H5, our benzene ring, that is benzene, sulfonyl, S double bond O, and then chloride. This is our benzene sulfonyl chloride. Now, let's check the reaction of primary amines with that of Hinsberg reagent. Now, the first one, Hinsberg reagent, the primary amines C2H5 and H2. There's lone pair on nitrogen atom. Hinsberg reagent, how does it react? C6H5, S double bond 0, and then Cl. Now, the reaction here is nitrogen to the lone pair cause and bonds up with this sulfur atom. As soon as this bond breaks up and then cause here, now their back bonding occurs automatically, and then the bond comes back here, and then there is a breakage of one bond, and then chlorine atom along with the bonding electron pair leaves. Now, therefore, Cl minus would be removed, and then we'd be getting here C2H5 and H. Nitrogen would become positively charged since it has donated its lone pair, and then nitrogen has bonded with the sulfur. Therefore, S double bond 0, and then oxygen, and then C6H5. Now, from here, let's check that this is our first reaction. The first reaction is here. Now, from here we have the nitrogen atom, this H plus proton, the bonding electron, this bond nitrogen is removed, and there is the bonding electron along with the two bond to fulfill the deficiency of the oxygen electrons, deficiency of electrons on nitrogen atom, along with the two bonding electron pairs. It comes and adds up here, and then we'd be getting C2H5 and H, S0 oxygen, double bond oxygen, C6H5. Now, our second reaction comes here. That is in an acidic medium. Now, NaOH. Now, NaOH, and the role of a base is to supply OH minus ion. This OH minus ion comes and takes away this hydrogen, and then along with the two bonding electron pair goes and adds up to nitrogen atom. Therefore, we'll be getting here C2H5N, negative charge, S double bond 0 oxygen, double bond oxygen, C6H5. Now, from in this reaction, a salt, this is a salt. A salt is formed, and then the Na plus remains in the solution. This is remains in the solution. Now, this is a soluble salt. A soluble salt is formed when primary amines react with benzene sulfonyl chloride. Now let's check for secondary amines. Now secondary amines. In secondary amines, C2H5 and HC2H5. Now secondary amines here, this is C6H5S, oxygen, and Cl. The same reaction takes place. The lone pair comes and attacks the oxygen atom. This causes up back bonding occurs, and then along with the bonding electron pair, Cl minus leaves. Therefore, C2H5 and H plus C2H5 is double bond oxygen, and C6H5. Now this, along with the two bonding electron pair, this comes and adds up to the nitrogen atom to fulfill the deficiency of electrons, and then we're getting C2H5 and C2H5 as oxygen, C6H5. Now this is our first reaction. Now the second reaction was reaction with sodium hydroxide. Sodium hydroxide gives OH minus ion. Now in this reaction, OH minus needs an acidic hydrogen to fulfill this reaction. But as we see here in this reaction, there is no acidic hydrogen in this product. Therefore, secondary amines react with Hinsberg reagent only up to this, the first reaction, and the second reaction does not take place. Now let's check the third one, the tertiary amines. Now in tertiary amines, we all know that there is no hydrogen, C2H5 and C2H5. Now lone pairs. Now let's assume that if the reaction took place for the first one, Cl. Now the nitrogen atom donated is, this goes up, this came down, and then this left. Now even if this reaction took place, C2H5 is double bond oxygen, double bond C6H5. Now the first reaction. Now even in this first reaction, we need an acidic hydrogen here to fulfill the deficiency of nitrogen electrons in nitrogen atom, but this reaction did not take place. Therefore, tertiary amines do not react either with Hinsberg reagent or sodium hydroxide, the basic medium, or the alkali. Therefore, we can conclude here that the question may arise here. One of the questions may be as such as amines, name the amines which reacts with both Hinsberg reagent as well as an alkali. That would be our primary amine, and the amines which react with Hinsberg reagent but do not react with an alkali would be our secondary amine, and then our tertiary amines would be amines which neither reacts with Hinsberg reagent as well as alkali will be our tertiary amines. So therefore keep that in mind, because primary amines react with both Hinsberg reagent and alkali. Secondary amines react only with Hinsberg reagent but not the alkali, and whereas the tertiary amines do not react either with the Hinsberg reagent or the alkali. Now therefore this is the end of the reactions of reaction with Arylsulphonyl chloride. Therefore, in this video, we have discussed two chemical reactions of amines, that is, reaction of amines with nitrous acid and reaction of amines with Arylsulphonyl chloride. In the next video, I'll be discussing the electrophilic substitution reaction of amines, and in the electrophilic substitution reaction, we'll be discussing the bromination reaction, nitration reaction, and sulfonation reaction.